Now, we have the empirical rule. Now, empirical rule is the same, is similar, not the same, but similar to Chevyshev's. However, in empirical rule, this rule only applies to a bell-shaped distribution or katong symmetrical. Ang Chevyshev's is mo-apply siya for a symmetrical skewness, mo-apply siya for a negatively skewed, mo-apply gyapon ang Chevyshev's nimo for a positively skewed. So, this application or this drawing, whether negatively skewed or positively skewed, is hold true gyapon ni imuhang Chevyshev's theorem. Now, for empirical rule, it only applies for bell shape or katong symmetrical. So, the empirical rule can be used to determine the percentage of data values that must be within a specified number of standard deviations of the mean. So, di ba, pareha siya sa katong imuhang Chevyshev's ra. Pero then again, iyahang difference is that it only applies to bell-shaped distribution or katong imuhang symmetrical na distribution or symmetrical skewness. So, empirical rule is based on the normal distribution, which will be covered in chapter 6. So, for the empirical rule, mo niyang iyahang rules na. Approximately 68% of the data value will be within positive, negative 1 standard deviations of the mean. Then approximately 95 will be within positive or negative 2 standard deviations of the mean. And almost all of the data values will be within 3 standard deviations of the mean. So, kani siya, ato aning this illustration would hold true for itong ipangkapitanan. So this illustration would hold true still for the empirical rule. So iyahan na lang is diba sa imuhang Chevyshev's is positive siya tanan. There is negative na siya. And then in this case, this is not 2 but rather negative 1. And then anina is 1. Then in this case, let's send back. Okay. So this would be negative 2. Then this is 2. Then this would be negative 3. And then 3. So, mao na lang niya ang difference. And then, atong i-move gamay, kay lahi man ang iyang percentage, no? So, for the negative, di ba, at most daw, all. Dapat yun na yung gamay nga part, sinapanig gamay na part nga blue. So, kana, ato na ikuan. Then, at least 95% kay 2 standard deviations. Then, 68, kanis for 75 man ni ganiha. So, ato i-move, ana. So, kana mo siya sa imuhang empirical rule. Now, why is it na dili tanan, di ba, for standard deviations, why is it not all of the data are within 3 standard deviations of your mean if it is a bell shape? Now, not all of the data is within 3 standard deviations because there are some datas wherein outliers exist, which we will discuss later on. So, munang dili tanan because of the existence of outliers. So, if you have outliers, obviously, ang ilahang standard deviations is dili siya mo follow kung unsa ang sa normal, which in this case, it does not have a standard deviation of positive, negative 3 of the mean. So, mo na siya nga, almost all of the data values ra, not all have 3 standard deviations. So, mo lang ni siya sa imuhang empirical rule. So, mo na ni imuhang hinumduman. 68%, positive, negative 1, 95, positive, negative 2, and then um, almost all, or 99.99 something, is positive, negative, 3 standard deviations. So, so again, it is applicable for bell shape only. So, kani siya nga mga percentage above, it does not hold true for a positively skewed or a negatively skewed data set. So, this computation, or this rule, only holds true for a bell-shaped distribution. So, kanira siya applicable. So, dapat balance imuhang both ends, no? So, ana ra na siya. That is how you, or that's what you need to remember when dealing with the empirical rule. Now, next is the existence of outliers. So, di ba, ganiha as I mentioned, maong not all kay tungod sa existence of outliers. Now, outliers are usually the simang sa dataset. Muna siya, mga simang siya because it is unusually small and or unusually large value in a dataset. So, naadyo mo simang. So, it's either gamay ra kay siya in comparison sa uban or either dako ra pud kay siya. So, a data value with a z-score less than -3 or greater than +3 might be considered an outlier. So, mao na to siyang sa imuhang empirical rule. So, meaning sa z-score, gihapon ka magbase. So, i-compute nimo sa imuhang data, makita nimo na ang iyang z-score is lower than -3 or higher than +3, it is considered as an outlier. So, ano na siya? Ang imuhang basis is using the z-score. Now, it might be, nganong na existence sa outliers, so it might be because an incorrectly recorded data value. So, meaning, pag input nimo sa data or pag transfer nimo upon data analysis is sayop imuhang natuplok na number baron. So, instead of 250, pwede 150. So, dako na ba na ang difference na 100. So, di ba, ina na siya. So, due to human error. The next is a data value that was incorrectly included in the data set, meaning wala jud ta siya labot ana mo nang nasimang siya kay it might be for another data set kung asa katunga number is normal ray para sa katunga data set pero naapi siya with another data set, so mo na siya nasimang noon siya. And then a correctly recorded unusual data value that belongs in the data set, or o kada siya nalan jud mga ingon ana nga mga simang na mga values, which is again parts sa imuhang dataset. So, in this case, di ba, sa katotong gi-measure ganiha sa z-score, kani, is makita nimo din ha nga 1.25 or no, not -1.5 is the farthest from the mean. However, di ba, ato ang guidelines in getting the outlier is through the use of z-scores. So, mao na siya ang imuhang timailhan. So, kana lang. Mao na siya ang imuhang guideline for determining the outlier. So, dapat kabaw ka mag-compute sa imuhang z-score. Now, another method which is wala dinhi sa imuhang wala diri sa PowerPoint, no? But there is another way of getting the z-score wherein, not getting the z-score, but determining the outlier, wherein we make use of the IQR. So, IQR or your IQR and your quartiles. So, you can get the outliers by getting the let's add another sheet. So, how do you detect an outlier? Using the IQR method. So, ang imuharang timailhan, how to get the outlier is, dapat na kay IQR, na kay quartile 1, and then na kay quartile 3. So, of course, you have your quartile 1 and quartile 3 kay mo na ang gamiton nimo sa pagkuha sa amuhang IQR, no. Now for getting the outlier is na kay mga lower ug upper limits. So lower limit, again you have your lower limit and your upper limit. Now whatever values ang nalapas ani sa imuhang lower limit ug upper limit, mao na ang imong i-consider as an outlier. Again, whatever values nga malapas sa imong lower and upper limit, that is what you will consider as part of your outlier. So for instance, let's say our value for quartile 1 is, and then our value for quartile 3 is, let's say, this one. So you have an IQR of 135. Now, how do you get the lower and upper limit? In getting the lower and upper limit, it is simply your Q1 minus, okay, di ba Q1 yung is lower maka, so ato ka sa ubos mo ng minus siya. So lower than Q1 minus 1.5 times your IQR. So mo na imong lower limit. Imong upper limit is your Q3 plus 1.5 times your IQR. So mo na ang pagkuha sa imong lower o upper limit. So if we substitute those values, so Q1 minus 1.5 times your IQR, and then your upper limit is your Q3 plus 1.5 times your IQR. So meaning any values lower than 3,262.5 and higher than 3,802.5 is your outlier. So if ever na gani data set diri, if ever whatever data set this belongs to, na iyang value is 4,000. So 4,000 is already beyond your upper limit. So it is considered as an outlier. So mo ni siya ang another method of getting for the or detecting an outlier. So again, you have two methods, either using the z-score or using the quartiles. So what method will you use during exams? It depends on what method is given. If you have the data, or if the data available or given only consists of the z-scores, and then you are asked to determine the outliers, of course you are to use the z-score method. If you are given the data that only composed of quartiles, of course you are to determine the z-score, or no, not the z-score, you are to determine the outliers using the IQR method. So that is how you detect outliers.